So hi, my name is Dor, and welcome to my talk about deserialization attack called Deserialize Killers. Sorry that the name is kind of shit, I didn't choose it, but let's go. So, a bit about what we're going to go through today. Botticelli's hell. So we're going to talk about serialization. Deserialization generally is a concept, is a positive development tool in code and in real-life scenarios. I'm going to go through deserialization in some languages, frameworks. I'm going to exploit where we can. I'm going to discuss it in Java, .NET, Python, PHP, Go. Then we're going to talk about built-in deserialization mechanisms. And we're going to conclude with some best practices and mitigation techniques in a pretty broad fashion, because I'm not going to go into every single one. So, my assumptions are that you'll enjoy this most if you have some familiarity with code, object-oriented terms, that this thing is going to be familiar to you. Some fundamental exploitation, generally and specifically in web applications or applications in general. That you will have chill, because I'm going to lie to you by oversimplifying a lot of concepts just to make it in time. But I guess like everybody does that in these kinds of talks. And the ability to go really fast, because we're going to go really, really fast at some point. So about me, my name is Dor Tumarkin. I've been an AppSec team leader, research team leader in Checkmarks for the past 2 years. Previously, I was a senior consultant at Cisco for 2.5 years doing red teams and penetration testing, having a lot of fun, and generally poking shit until it explodes for the past 7 years. I'm also father of this beautiful, beautiful and smart girl and this stupid dog, who I love very, very much. I'm based off Tel Aviv, Israel, so represent. And I talk a lot. I talk fast, so I hope you're fine with that. And opinions obviously are my own. Naughty words are my own. Shitting on other vendors, it's me. It's not the company. So without further ado, let's get started. So Wikipedia describes serialization as the process of translating data structures to object state into a format that can be stored or transmitted and reconstructed for later use. I think that this is a very, very good definition. You have this thing in memory that has references and members and pointers and all that shit, and you need to push it through a wire that is basically meant for pushing bytes and by extension strings, right? So transmit it over a network, put it in a database, or whatever. You need it in a byte format or a string format. But I'm a technical guy. I like knowing what things do actually look like in real life. So these are some native language examples. This is the Java object stream format that is sort of binary. We also have this Python pickle right here, which is a proprietary format. We also have the generic types that everybody knows, CSVs, XMLs, JSONs. And specialized formats, which I'm not going to go into, they're kind of out of scope for us, like CBOR and protobuf. Okay, so basically a serialized object can be transmitted over a network, stored in a file, written to a database, and most standard serializers have access to multiple classes in their space. Basically, they can reference almost any class inside of them. Obviously, it would need to also implement some sort of serialized interface in many implementations, but we'll get to that, and it doesn't really matter that much. So I like to think of serialization as sort of like soup in a cup. You take a bowl of soup, you dehydrate it, you just extract its essence into a powder, and in its powdered essence form, it can be distributed to your local supermarkets or stored in a warehouse. And I think this is a very apt comparison for that. And if you want your soup back, you just add water, and you got your thing. And like I said, I'm a technical guy, so I want to see what that looks like in code. Using this serializer called Xstream, I'm going to call it Xstream because I keep confusing it, but it's Xstream. We can see in lines 1 to 4 that I defined some basic primitives. I set them into a class called a testing class. I created, and in line 6, I'm creating a serializer, the Xstream serializer. Then, convert it to XML and printing it out to screen. And the console output is, as you expect, just like a XML wrapper with a class name and all the primitives, all the little members inside. And this format, you know, very human readable, transmittable, storable, whatever you need it to be at this form. Then we can reconstruct it using very similar code, right? I mean, I have from XML here, and I pass the XML to it, and then I get name. And the name that I put into that serialized object originally was John Doe, and I can get it back from the now reconstructed object. And the important thing to remember about serialization is that you have like two ends. You have the serializer and the deserializer. They can be independent of each other, but they have to match. You need to have the parity to deconstruct and reconstruct the same objects in the same manner on both ends. Otherwise, you're going to have errors. So talking about real-world examples of where this would be useful. So for example, Struts2 has a REST API based on XMLs where you can pass objects to the Struts API. And it gets deserialized into an object. If you have an application, for example, a game where you want to save your world state into a file, you can just deserialize all your world parameters, save those in a file. Very handy. It's also useful for distribution of work. A good example is that a lot of distributed Python work is done by pickling. You can pickle like classes of work and transmit them, and then you're fine. You distribute it. And you know, there's just so many uses for this thing that can go on forever. So, isn't serialization amazing? Let's rewind a bit. Through all these wonderful compliments. This slide, I love it because almost any class is fucking money. I mean, that's the gist of it. That's where everything rates apart at this automagical almost any class line. So let's talk about exploitation. But before we do, there's a bunch of guys I want to acknowledge. I'm really standing on the shoulders of giants here. A lot of aggregated data from other people's research. Chris Frohoff, Alexander Mirosh, Alvaro Munoz, James Forshoff for their work on Java and .NET deserialization. And Manu Mo, who disclosed the CV that I'm going to demo later just for completeness of understanding what an attack looks like on a product. So, moving on. Struts2. Anybody familiar with Struts2? The infamous Struts2. We're not going to talk about the Equifax hack. That's a completely different attack. This is also, though, quite similar in its impact. So, open source MVC framework for creating web applications, and somewhat renowned garbage fire of critical vulnerabilities that are easy to exploit unauthenticated. I don't know. They say it's coding over configuration. So instead of configuration, you have the most spaghetti code I've ever seen. But let's not just shit on struts. Let's also demo what's going on. So we have your struts server on the left side. On the right side, we can see the REST API demo. This is built into struts, and we're creating a new order right through this sort of nice web UI. And then, you know, here I demo how you can create it from this XML. You can just submit an XML to the web application, and there it is, created. Let's try something a bit different. So let's submit this bad boy. I'm going to go a bit into detail later about this malicious XML. The important part to remember or observe is that its innermost classes are process builder, a reference to the start method with cmd \c calc. So I'm going to submit that request. And I get this error 500. Anybody who's ever tried something on a Java server knows this error screen. So what happened? What did I submit? This is a gadget. I'm going to describe gadgets a little more succinctly later. What's important about this gadget is that it's based off of classes available in Java and in the Apache Commons library, which is very popular. It's already part of struts, so there's no it's not custom struts or anything. This is out of the box from 2017. And I think that the interesting part about it is that it's impossible to heuristically detect it, because we have this API that's receiving an XML as an input, and I'm submitting an XML to it. There is no like malicious backtick for SQL injections that you can qualify or something like that. And if you blacklist these classes, then I'm going to find something else probably. So heuristically, it's equivalent to a good request rather than a malicious payload. So let's see what just happened. Let's check our server. And oh no, it's calc. So our old friend calc. So what happened really, like under the hood? There was a naive deserializer in struts, and spoiler, it's extreme. I chose it for a reason, not just because it's very readable, but because it's part of this demo. And you can see in their code how they create this same generic constructor, like generic extreme class that I created earlier. And they fixed it since, and this is an interesting fix. They deprecated the old call, and they also, like as you can see in the bottom half, they also stripped all type permissions, which means you can't deserialize anything anymore. And then they start whitelisting and adding classes that you can deserialize now. So this is a really robust solution by removing like these potentially malicious classes or any classes that are unexpected. So, like I said, that was a gadget chain. That's a nickname for sometimes nested malicious objects that invoke whatever your payload is. In this case, it was Process Builder. They're very difficult to design sometimes. Sometimes they are very straightforward. In this case, that was a very complicated example. What you do need to know about gadgets is that they must live off the land. You can't invent classes or use classes that are not imported by the code base, because then it's just not going to serialize, it's just going to say the object doesn't exist. It must parse, because if it doesn't parse, it's going to fail way before it gets to deserialization. It's going to fail at the parsing phase. And it doesn't always have to finish its work, because the error 500 we saw, unlike errors we're going to see later, isn't about creating the wrong type of object or unexpected object. It actually fails to create the wrapping object and only creates the ones inside, but that's enough for me, right? I mean, all I wanted is the process builder. I don't care for the rest. So it's owned, not by me, but owned, and we can move on to other technologies. So JSON.NET, I don't know if you're familiar with it. It's a really good .NET JSON parser. And it's somewhat endorsed by Microsoft. You can see examples of it. It's not by Microsoft, it's by Newtonsoft. It's a very handy little parser. And this is our deserialization code, where I create a deserializer and deserialize some JSON. And from this order object, I get the order ID and user ID. And I pass this JSON object to it of type deserialization.order. That's like the project name and the class name. And some data inside it. And it's working as intended. It's not very interesting. It's cool. But what would JSON convert deserialize do with this fella? So this fella is an object data provider, which contains a system diagnostic process call to start, very similar to the process builder that we went over earlier. And when we pass it to this order JSON convert serialize object, we see that it pops calc. So again, this is a small demo app that just unparses, like deserializes this object, but as you can see, it works like a charm. For this instance, there are actually good implementations. So this implementation is bad, where you're casting order right ahead of the deserialize call. But this guy's good, where you have order in your generic notations right before the function, like inside the function header. So why is that? Because the implementation knows to look at the generic notation and say, this is the type I'm expecting. And if before object creation it sees that the type doesn't match, it knows to fail. It fails during deserialization before object creation. So without this, anything gets deserialized. And there are ways to get this to accept multiple classes, but that's not the point. The point is that this is very vague in terms of usage. Do I put the brackets before? Do I put the casting before? The generic notation? Not everybody knows the difference. And even if you do you think of it when you're writing a line of code, right? Like, do I notate? Do I cast? They both work just as well. And we saw an exception occurring, and it was an invalid cast exception. So we're casting the wrong object, so it fails. But again, when we're doing the casting, way too late, and we own. So this is another interesting use case. So this used to have a Pickle Rick meme. It's a dead meme now, so I removed it. Stop using Pickle Rick, please. So let's consider the following Python code. We have this trade class. We're creating the trade class, and we dumps it using pickle to very expected output. As you can see, it's a bit unreadable, but because it doesn't really make all that much sense. But you can see the data, you can see the class name, you can see sort of what you need to see. And when you load it, as you'd expect, you can see it was successfully deserialized, and we got John Doe again. So for strictly typed languages, it is an easier time for developers to discern what classes are what's happening, like what classes are being created, what classes are being handled. And for untyped languages, on the other hand, it's actually quite difficult. You can do some type detection, but not in pickles, by the way. Pickles are completely vulnerable, says so in the API, so don't use pickles if you're expecting untrusted data, because you won't be able to detect the type before you get started. So we have these two little samples. I'm going to use the Windows samples because I'm lazy, and that's the VM I set up. And I got this unpickling code on the left, and on the right, we're expecting to use pickle loads, and obviously I get calc. Like, it's very easy. Python, by the way, has a very interesting internal implementation for classes where you have the underscore reduce underscore method, where what it returns is the pickled form. And so if in this example, I'm returning the pickled form as a tuple of OS system and the parameters I want to pass to it, and then I dump that object, and I dump that class, and I get the reduced form as a pickle. So you can actually pickle literal code or literal calls to methods in Python, which is very interesting. So basically you're spring loading a deserialization bomb using pickles or using the reduce method, which is cool and owned. Let's talk about PHP a bit. PHP is a strange creature. It's a very specific sort of exploitation method. Deserialization, when you deserialize using native PHP, it just goes through the underscore construct and underscore destruct methods, which, start of life, and then deconstruct, end of life, in your current running context. And in between, it sets the members. Like it constructs, it sets the members from your deserialized object and moves on. So you can't really trigger anything particularly interesting because PHP has built-in limitations by its very design that save it from being, roasted. So anything built in, like operating system calls, like exec, eval, all that sort of thing, they're not actually classes because PHP isn't object-oriented at its very core. At its very core, these things are basically language constructs and not functions that belong to a class. So it's not part of any class, and by that, it essentially whitelists what you can call when you deserialize. And by that, I mean you can only attack custom classes or imported classes and anything that is custom implemented, but not the actual language. So it can still be exploited. There are exploits out there that are specific for deserialization and PHP, but it has to be done very contextually with a lot of thought. So moving on to Go. Does anybody have any idea what Go deserialization would look like? Any Go developers here? Any idea what deserialization will look like in Go? Yeah, but how is it vulnerable? How would you? So So in Go, you really can't exploit deserialization. Deserialization exists in Go, but because Go doesn't really have classes, it has structs and interfaces, you can't really spring load anything. You can populate a struct from deserialization, but there is no active code beyond that. It's more like parsing than it is deserialization, because there's no constructors, no destructors, nothing to spring load. Okay, so that's Go. But at this point, we have some idea of commonality between language and exploitation. Basically, deserialization streamlines converting objects to text and texts back to objects, or string or bytes. So it's dangerous if and only if you use it on untrusted data. If you do it internally, who cares? I mean, if nobody can taint that, then you're pretty safe. But remote and naive deserialization is basically RC delivery systems. That said, it is, in many cases, only local and trusted, and for some of the examples that we saw, like APIs, you can just replace it with a parser. You can build your own. So it's not like there are whole technologies designed to distribute objects via serialization, right? Yeah. So moving on to message queues and deserialization. Message queues are literally there to distribute messages. It's exactly what you expect if you've never worked with one. You have like a queue, you push a message into it, somebody pulls the message or publish and subscribe. Depends on your implementation, how you describe it. And there are agnostic MQs where it's just strings or bytes. There's no like wrapper functionality around it. Those are obviously not very relevant to us because we want the whole thing. We want things that allow sending objects, where your end-to-end solution is serialize, publish, read what you published, and then deserialize it on some other node. Are they basically end-to-end delivery system for remote code execution bombs? Yes. So Java JMS is documented, well documented, is vulnerable. There's a really good talk by Matthias Kaiser from Black Hat 2016, Owning Your Java Messaging Systems, that describes multiple ways of exploiting it. And this code snippet here, this JMS thing, this little snippet, is just like a basic on-message event where you receive a message, and you get the object, and as soon as you reference this getObject method without verifying what's in there, it explodes, like it runs. I'm not going to demo it because you've seen enough calcs for the time being. So that begs the question, what about .NET? Because whenever there's something cool about Java, we go looking for it in .NET because one's a knockoff. So it does have Microsoft Message Queue, MSMQ. It's kind of cool. It's ancient, but it's still in use. And when I say it's still in use, it's still a feature in Microsoft Windows and up to 10. Like, it's still there. You can still enable like an MSMQ server on your system, and it's baked into .NET as part of system messaging DLL. So it's still there. And this is what a message queue kind of looks like. It's added to your computer management. You can see the queues. You can even read the messages that are waiting inside the queue. So it's there. And it has two object serialization suites or formatters, one for XML, one for binary. And we embarked on some of our trademarked research. The only reference we could find for any security issues pertaining to message queuing in Windows that isn't a particular CVE, but rather the technology itself that's bad, is a reference to the binary message formatter in Friday the 13th JSON attacks on the talk, the paper, which is, again, highly recommended. But that's it. All we know from that is that it uses binary formatter and is therefore likely to be dangerous. So, being the savvy researchers that we are, we browsed to msdn.microsoft.com to look into it. And we saw that binary message formatter is very efficient and fast to parse and has faster throughput and works on pure speed. And you might ask, how fast does it go? Too fast. It goes too fast. It doesn't do a lot of vital checks that would have been saving its bacon at this point. So let's look at the sample code from MSDN. There's a receive message method, very basic. It creates like a queue object. It sets the formatter, and it receives a message, reads the body of the message as a bitmap because it's a binary, like it's a byte stream, and tries to save that to a file. So we take this nice little exploit, known gadget called type confused delegate, and we push it into a message with the binary message formatter to see what happens on the receiving end. So we have this basic MSMQ send and receive code. We push the message into the queue, and we read it using the Microsoft code and pop. Also, we can see that same casting error from before. And if you can see it, it's highlighting the bad cast for bitmap, obviously because I didn't send a bitmap. It was not a bitmap. So Microsoft samples being dangerous isn't great, but it isn't news either. There have been several talks about demo code from Microsoft being vulnerable, like from MSDN. So we did some digging into more official stuff by Microsoft about the message queuing system, and figured, maybe it's bad because they're trying brevity. I mean, it's demo code. It's only intended to read like a message, and maybe like they have something else. So we went on the Microsoft GitHub and found this solution called large message queue. And it's just a basic forms application that you have this queue, and you send a file, like a bitmap. You read the file from the same queue, and you're done. Basically, it's a wrapper for the existing message queue that is designed to handle some loss when reading the image from the message queue. So we took the same exploit, and we pushed it into the same queue being used by this Windows Forms application, and crafted the same malicious messages before from a different application. So now it's in the same queue that's being read, and we click receive, and bam. So toy. So as you can see, as soon as the binary message formatter is set, like the immediate following line is dereferencing like the body member of the message. As soon as you step into the message.body, it's cock a clock, baby. So very cool. The exploit that we used was for .NET 4. Now that project is kind of old. It's for .NET 3.5. So we figured like nobody actually published like any, or at least that I know of, like exploits for .NET 3.5 for deserialization, because a lot of the gadgets, like I mentioned before, depend on classes that you have available. But we did successfully modify one of the existing gadget chains by changing around some versions and tinkering with it, just very minor tinkering, just to get it to work on .NET 3.5, which is very, very cool, because then you can consider any usage of the binary message formatter since 2007 as vulnerable. So, I mean, it's ancient history, but, still there. And binary message formatter is exploitable by default. You can't explicitly set types. I couldn't find a method of setting a type for binary message formatter, or a check, or some sort of canary, whatever, for detecting object creation before it actually triggers. And it's intended for remote use, guys. It's a message queuing system, so they can't go like, yeah, it's local. Don't use it like that. There's no other way to use it. And in what scenarios did we observe this class being used? So you can find a lot of demos, white papers about using it, a lot of snippets on GitHub and stuff. And it's recommended for high throughput and large messages and complex objects. It's not particularly popular in open source. But that makes sense, because message queuing is sort of a middleware solution. So you're going to find it in proprietary implementations. You're going to find it in internal enterprise networks. And it's anecdotal, it's not evidence, but I've spoken to some DevOps people, and they knew exactly what I was talking about. So it's very, very interesting in that sense. We did observe some traces of it in older implementations. Like, it's not used in newer versions, but I guess it was pruned because it's old. That said, it's still available in older monoliths, I suppose. So where else did we see it? Like I mentioned before, in like GitHub, but we also found it in books. So we have a vulnerability in books, folks. This is exactly the same way, like you define the binary message formatter as your formatter, and at some point in this long link expression, it dereferences the body twice. So that's twice. We found it in other books, like F# by O'Reilly. Oh, by the way, that previous book was dated 2015, so it's not that old. It's like it's still in people's minds. It's still sort of part of the ecosystem. It's still built into .NET. In F#, in this book, and that leads to the only reasonable conclusion, which is don't read fucking books. I try my darndest to adhere to that. So obviously we confronted Microsoft, and as they said, does not meet the bar for security servicing. Fantastic. Closed, no longer monitored. You're dense, but you're also owned. People who were actually good sports about it were O'Reilly. They're like, yeah, we'll notify all the editors of all the books that you mentioned or that were relevant to O'Reilly. Not all of them are O'Reilly's fault. Aware of making any necessary changes before printing them. I think that's the spirit. That's how you do it. So moving on from exploitation, let's talk about additional risks. Deserialization isn't just remote code execution. You can add checks, you can add other things, you can use it safely, but there are still additional risks to that. So deserialization errors, obviously, as you can see, they throw exceptions and, erroneous behavior and all that stuff, which is not very sexy, but, it's part of the whole thing of security, I guess. What is interesting to me is that in some languages and some implementations of deserialization, the object is built from reflection, in the sense that it doesn't use the same constructors that you think it uses. It doesn't use the same setters that you wrote. So it might be bypassing your logic. It might be bypassing your checks, and you wouldn't know. For example, if I deserialize an object that has an integer representing an object ID, like an order ID or a user ID, I can set it to -1. And, it's not going through the setter that makes sure that ID is a positive integer or isn't already taken. So, you're deserializing naively, and I might be bypassing your logic through that. And that's very, very interesting, because even that means that even if you do check for classes and everything is on the up and up and you can't deserialize a malicious class, I can still do a lot of harm from naive deserialization. So you can't assume anything about values and logic when you deserialize for some implementations. For some it works just fine, but you would be surprised which deserializers do and don't go through setters and constructors. So from an industry perspective, I think that it's very interesting to see just how many critical vulnerabilities are found in vendor provided products. I bet some of you bumped into it. Some of these were wormed or converted into a worm that for crypto miners, for stuff like that. It's very, very cool. I would suggest, if you're interested, just follow up on this list just to see what's up. It's also part of OWASP Top 10 now. OWASP is known to sort of fit themselves to the spirit of the time. So they decoupled deserialization into A8 from A1 injection, which is broad. And it helps them catch the media buzz for this, and also bathe in some industry tears, which is lovely, which is exactly what I'm doing right now. In terms of CIA and stuff like that, you get a bunch of CVS-10s and a lot of critical vulnerabilities going on. When you get to a 10 or a 9.8, it's like total game over, complete destruction. But I can also, like I mentioned before, tamper with your integrity by bypassing logic and stuff like that. And obviously there's the whole stability issue thing. So this is Mark Reinhold. I don't know the man. He's a chief architect for the Java platform at Oracle. And he says that serialization in its current form was a horrible mistake made in 1997. to that extent, Oracle is planning on dropping support for serialization in Java in its current form. And I have to say that this does not matter. This does not matter at all, because if you tell me that a software update is going to brick my code, I'm not going to install that software update naturally. And if there's Java Oracle and there's other Java JVMs, I'm going to switch over, because I'm not going to change a line of code. And when I say me, I mean enterprises that have been relying on this code for decades, sometimes. So it doesn't matter. You can't unring this bell. There is nothing you can do. There is just the regular cycle of testing and finding and mitigating, and or getting hacked and crying on TV. But this approach is not going to work. Or at least that's my opinion. We'll see that I'm right. So mitigations, do's and don'ts. As we saw before, catching exceptions from failed deserialization is too late and probably irrelevant, and you lose. And when you make assertions, it's the same thing. I mean, it's going to be the same thing. It's going to be way too late. Actual mitigations are about never deserializing untrusted data unless you have to, and I stand by that. I don't think you should deserialize untrusted data. But particularly in untyped languages, you're going to have like the same challenges that we mentioned in Python. And untyped deserializers is very important. You saw the constructor that I used for my first demo. You saw the constructor in struts. Those were untyped. That should really raise your eyebrows. You have this thing that magically converts any object to something and then converts it back. So it's obviously inherently part of the paradigm to always serialize by defining what types you expect. Otherwise, you're going to get these gadgets that, as complicated as they may seem, not impossible to design, obviously. So there's also the matter of dangerous types, which again, sort of like the logic part, but also what I mentioned in PHP. If you have like a class that is dangerous and can save files or overwrite files on one end of your application, and you deserialize on the other end of your application, the deserialization can talk to that class without you knowing, and then you're screwed. Despite trying your best to not deserialize or use a language that is deserialization safe. And obviously, always whitelist the classes you're expecting. No wildcards, no nothing. The exact classes that you're expecting. So always test your deserializers when you're working with them. Even if you are using a well-defined whitelist, check if you can nest objects. Test if you can maybe inject the wrapper of the object, or just tinker with it, see what happens. Always fail before you create the object, because if you fail after object creation, like the exceptions that we saw, it's not good enough. And if your object has logic, check that that logic is gone through in your code flow. And if it doesn't, you need to re-implement this logic after you deserialize. Don't just assume that because the object constructed correctly, it's going to be a good object or safe for you to use or consume in its deserialized form. If you're still very, very paranoid about this, you could build your own, right? Just parse it, grab the variables, put them in a constructor, and use that. And it's very poor performance. None of your code is going to be as fast as built-in deserializers, especially binary ones. It requires work on your end, because you're going to have to do it for each and every class that you deserialize. But it's secure, maybe? I mean, it's up to you guys, right? But it is a less magical idea than serialization, which does things for you, and you can't be entirely sure what exactly is going on. Could be dangerous objects, could be bypass of logic. So, as a conclusion, deserialization is kind of awesome, but maybe it's too awesome. It's too magnificent for this world. And it's a classic example of things working automagically. And that's sort of a key concept in vulnerabilities in this industry, is that it was doing something so magical that nobody knew what it does until they did. It can be very, very deadly. And from RCE and to manipulation. There's still a lot of potential areas to explore. We just bumped into this binary message formatter a couple of months ago, added post hoc to this presentation, but I still think it's cool. Go out there, look for deserializers. It's going to be built into other things. It's going to be very interesting for you. And never trust a deserializer, always test it. Questions?
Have two, but I'll do one and then wait and see if other people do.
Sure, go ahead.
First would be the MSMQ stuff. Is that remotely detectable? Just like if you nmap a Windows box and does it tell you that
it's an open port.
MSMQ is there?
You can remotely send to message queues. I didn't tinker around with their settings too much, but obviously the default settings for a private queue means it's remotely accessible in a local network. So if you want to weaponize it, go ahead, sir.
So I'm more interested, will nmap actually tell you this is an MQ series?
It's got its own unique ports. So
nice.
Very fingerprintable.
Thanks for a great talk. Is there any examples of people using JMS safely, or is this the way to do it?
What do you mean? Sorry, to use what?
JMS.
Oh, yeah, you can. You can just try to get the type from the message before you open it. It's just the idea of getting the object before you test it. It's a lot like regular mail, like screening for bounds and shit. So, but yeah, you can. And in Java, there's also a lot of very simple implementations that you can implement on the object input stream to verify types and stuff like that. And that also applies by extension to JMS. So you can. Just, the thing is that this is hastily written and very basic example, and it works. And that's kind of the problem, isn't it? That it works without any sort of checks, and that's why it's still out there in so many forms.
Well, thank you for the great talk. Very interesting. I just wanted to ask you, what is your approach in finding the gadget change to execute remote code execution once you know that they are using untrusted data to deserialize the object? So
first of all, none of these gadget chains, especially the complicated ones, the Java one and .NET ones, are not mine. I credited the guys who developed it. It's actually very difficult to make something specific. However, you will find that this applies. These can work on very specific deserializers. There aren't that many variants of deserializers out there, so you go by what deserializer is actually being used. And I would imagine that for proprietary implementations, you can find out by just checking for the exceptions. Like if you have a black box, just look at the exception. I was able to detect there's LOS formatter, for example. It's got very clear errors that tell you what it is. So you already have a set of deserializers and potential exploits in ysoserial.net. And now all you have to do is find the unsafe usage. Excuse me? This guy over here. There's a question. Thank you. Over here. This guy, first line. Thanks.
I know that you mentioned Pickle for Python. Is there any safe way for doing deserialization in
Python?
Yes.
I didn't. I'm a negative guy, so I just go for the bad. I don't know if there's a secure solution particularly. There probably is, but the concept of typing in Python is complicated. It is good for distribution of workloads if it's just, if you can trust what you're getting and just, encrypt the stream and authenticate. Just make sure that the channel itself is safe. And then you can, the problem is deserialization of untrusted data. If you disable one of these nodes, then you should be fine. But it's on it's on you. So you have to make it secure.
Okay, second question. When I believe you were talking about JSON with the casting versus the
generic
stuff. Could you say it was customer object? Mm-hmm. Can you do a member of the customer as one of the malicious objects instead, and then the top level stuff is still a customer, but say his address is the malicious object?
That's a very good question. It's a very complicated question because it depends on the unique implementation of each of these objects. So For some of them, it should be possible but complicated, and it depends. For example, if you pass an object that has some sort of data provider interface that is part of the implementation of the class, then maybe you can shove a data provider, like an object data provider that we saw here, and I also know that XAML reader object provider is vulnerable. It's in another gadget. So maybe you could nest it into this customer object, but generally, if it's just data types, it might not be possible. It depends on whether it's possible to nest and how you can reach classes on the object graph that are vulnerable by design, or I don't know, like you can chain them into this gadget chain. I would say that it's theoretically possible because the Java thing I showed you guys is a very complicated object that starts from a map and goes through some internal types and a lot of interesting things, all the way down to process builder. So it's potentially possible.
I was hoping because JSON doesn't seem to be strongly typed.
Yeah.
You have more flexibility there.
Maybe. It depends on nesting capabilities. Okay, so need to wrap up. So thank you guys for attending.